Thank you, Patrick. So this is about cost estimation. Is it muted? Yeah, read that. Good. It's about cost estimation in shipbuilding and how the software system CostFact can support such estimates by leveraging the data of the design model. The presentation is divided into 3 parts. In the beginning, I will give you a very brief introduction into the CostFact system. Then it's about how can we access the data of the design model, and then finally, when we have them in the system, the CostFact system, how can we make use of this information? Cost estimation software CostFact. So what is CostFact? Software supports cost estimation and also optimization. And in practical terms, CostFact is an alternative to working with Excel spreadsheets. So when you think about the complexity of a cost estimate in shipbuilding with lots of 1,000 rows, several users working at the same time at the same project is spanning over a period of several years, perhaps consisting of multi-hull ship series where we have to consider learning curves, non-recurring cost, and so on. A lot of different suppliers. Well, when we take all this into account, it's, I think, obvious that Excel is not always ideal. And so the approach of this system is to support the user by a lot of different features, which are particularly for shipbuilding estimations. So the user is supported to be more efficient, to be quicker in generating a cost estimate, to avoid errors. The estimate itself, the reliability of the estimate will be increased, not only increased, but it will be also quantified. So it will be possible to say how reliable is this estimate. Well, the last advantage shown here refers to the process of cost estimating, so that we have, when we're working with different versions of this project, reusing information from historical projects, that we increase the transparency, so that we always have full information about the cost development, about the sources that we have been using for this estimate. So shipyards working with CostFact, so they're here in the United States, a lot of in Europe. In Germany, the majority of the shipyards are using CostFact as a central tool for cost estimation. And farthest in the east is Larsen & Toubro, one of the major shipyards in India. Just one single screenshot window from CostFact to give an idea how it looks like in cost estimate and CostFact. So that is a major view over the same structure. On the left side, you have the breakdown structure, the Swiss code. Just an example here, when implementing CostFact, the first step is to import your own breakdown structure into CostFact. Then we have the columns with all the information about the quantities of labor hours, of cost, and what is desired for the user, and then some possibilities to filter, to analyze the cost. The major advantage of CostFact, or the central idea of CostFact, is that we have a system that accommodates really all information, all data, which is relevant for cost estimation. So the center is always a current project, and then we have the possibility to import the specification which we receive from our prospective client to manage the supplier quotations, not only by comparing them in terms of cost, but also in terms of value, in order to use those supply which is of highest benefit for us. We can work with cost escalation and all these different things. When working on a project, we can always very easily access existing historical projects in CostFact. And the one thing I selected for today on the left side, that is a utilization of technical parameters. Technical parameters might be main dimensions when we only have rough information, or on the other side, if we have really detailed information, perhaps already the 3D design model available in ShipConstructor, to make use of this information to support our estimate. So how can we access this design model data? Well, the first question is, why should we do this? So of course, it is of a benefit, of advantage when we are able to mirror the design model on the cost side. So a very simple example is when we have the information available in the design model about the bill of materials, the BOM, we can just import this information into CostFact, including the information on the service coding. And then on the other side, from the ERP system, we just attach the cost information to it. And so we already have our first cost prototype generated. If we do not have this detailed information when we are in the early stage of the design and have not the information about the material list, we can still use this technical parameters, this technical information to parameterize our cost model. So in order to work with cost estimation relationships to predict cost based on main dimensions or information like this. So once we parameterize our cost model this way, we can use this parameterization if a change occurs to update our cost model, and then so by updating the design information, and then automatically due to this parameterization the cost information will be updated. So to do this, to access this information, we have some out-of-the-box interfaces in CostFact. So to import information from the design model, to import information from the ERP system, so also to exchange data with Excel files, of course. So there are out-of-the-box interfaces, which can be used right from the start. So in the course of trial installation of CostFact, typically when CostFact is implemented for permanent use, these interfaces are customized in order to increase automatization degree. So how it looks like when we have this information CostFact. So I'm using here very, very simple examples just to keep it transparent. So here we see project related. So a project is one estimate. We see the information which can be defined by the user. What are the technical parameters which are relevant for our cost estimation processes? Here on a very rough level where we look at main dimensions like length overall. Everything can be entered manually in the beginning. So some shipyards are generating their first cost estimates based on 10 or 20 different parameters. So that's not the problem to enter them manually. But of course, if we are trying to leverage the design model data from ShipConstructor, this is not practical anymore. And so we can make use also still in this window to click on this button, cut update, and then we can import a CSV file in our out-of-the-box interface in a defined structure to import this information, CSV file generated by ShipConstructor. And then there's a control window where we see, has there been an update? Is everything in line, or do I have perhaps in CostFact length overall in meters, and ShipConstructor delivers the length overall, but in another unit? So this is can be controlled and checked by the user, and then finally, after confirming, I have initially the data, or later in cases of updated, the updated data in CostFact available. So here on a very rough level, on the project level, as we have the information about the service coding and ShipConstructor available, I can import this information also, of course, with a reference to the service code, to the product hierarchy. So in this way, I have this information in CostFact available, and then by clicking the button update, I can always refer to the latest version in ShipConstructor. So and once I have this information available, what can I do with it? So here I start still with simple examples. How we calculate in CostFact. Let's say we are calculating something manually, and if you look at the window, at the button, at the background, if we have a line, a cost item for steel work. So of course we can enter the number of labor hours for steel work, 107,000 in this case, we can enter it manually. But the alternative is to double click on the cell and then open the window which is shown in the front, where I can then select one of the parameters which are uploaded and referenced to this project. So here the user selected the hull weight. We have this information available about the steel weight of the hull provided from the design model. So then we can refer to this parameter and enter, in this case, manually based on our experience, our knowledge. As we know, 1 ton steel requires 150 labor hours steel work in our shipyard. We can enter this relation here plus 200 labor hours for some initial work, confirm, and then we have calculated with reference to the steel mass the number of labor hours for steel work. So later, when I return to this window where I entered all this information or imported it from the CAD system, I can analyze it. Is it in use to predict cost in our estimate? So here in this case, I see, okay, the steel mass, after selecting it, I see on the button and the panel, it is used in this example for 2 cost lines to calculate cost or labor hours. And then, of course, if I update this information, the numbers, when confirming the entire project will be updated and recalculated as well. So, of course, in practice, I mentioned in the beginning, and cost estimation project with 20, 50,000 lines, cost lines, not all of them will be parameterized because it's not possible to enter for all of them such formulas. So what can we do with the remaining cost items if there's a design change? So the approach to solve this issue is that we can define here across projects the impact of the cost drivers, so the different parameters from our design model, to the different parts of the ship, so to the different SWABIS elements. So this is defined here. So on the right side, I have all the cost and all the SWABIS elements available by selecting here this simple example, thanks overall, and then moving the elements in the middle list. I define that these selected elements of the ship are impacted and probably will have a cost change if the length overall changes. So with this information, if I then update the technical parameters, CostFact can scale or will scale under full user control all these cost items which are not parameterized, just by comparing the original or the previous number of the technical parameter, and then after the update, the new value. And then there's some more functionalities. Is it the number which has to be increased or decreased, or the cost and so on? That works in the background, but always with the possibility for the user to control everything, what happens, and everything is written a cost history for documentation purposes. And so in an ideal project, the procedure is that we have either a new project and we have a template which contains all this parameterization. And also we have the information about the scaling for these cost items which are not parameterized. And then I just enter the technical parameters, or if available, importing them from ShipConstructor, confirming, and have my first cost estimate created. And the same then, if a design change incurs, I just update the numbers, technical numbers, and then based on the relations in the background, the project is recalculated. So in the next step, or in the next part, I will have a look at how can we create such cost functions or derive them. So in my example here in the beginning, I said, well, I know 150 labor hours are required per ton steel for steel work, but how can I get this information? And for this purpose, CostFact also provides a feature. How can we derive such cost functions? And that works by analyzing existing projects, which we either calculated or estimated in CostFact, or initially uploaded them into CostFact from Excel spreadsheets. So, and the idea, I think it's very clear for everybody who's working in the shipbuilding industry. The idea is to say, well, we have different systems or different parts of the vessels, and for all of them, we can define main cost drivers. So here in this example, it's about the cost of the propulsion system, and then probably the required propulsion power will be a main cost driver for the resulting cost of the propulsion system. So, and on this basis, we can analyze existing projects, which we have in the CostFact database, and analyze, is there a clear relation between the requested propulsion power and the cost? And if you see like here, nice example, yeah, there is a more or less strong relation. We can calculate the so-called regression function, and then we can store it. And in the next step, if there's a new project and we only know the requested propulsion power, we can apply this function to get our first cost estimate for the propulsion system. So how does it work in CostFact? Everything's done in one single window in 4 or 5 steps. So the first step is to say, what do we like to analyze? So we select the parts of the project, so this web is elements. So here in this case, just one element, the propulsion system, is also possible to combine several ones. So in the next step, in the next list, we decide what do we like to analyze. Is it the cost? Is it material cost or labor cost or number of labor hours or also the tons? The mass can be analyzed. That is selected, and then we also select the cost driver. So here in this case, after selecting the propulsion power, CostFact proposes length over all propulsion power and the speed as possible cost drivers. The user is free to show all existing cost, all existing parameters and select other ones. So once we made all these selections, we can start the analysis. CostFact runs through the database, shows all projects, which provides information about the parameters, the selected parameter, and the cost or number of labor hours, shows them in a list, shows them in a chart. The next step, and that is the reason why this is done always manually by the user, not completely automatically, is that it's really up to the user to have a look at this and to decide by themselves, can I work with the sample data? Is it reliable or not? Well, you can always, as soon as you have 2 reference projects, you can create a line going through them and you have a result, but we don't know is it reliable or not. So here it's up to the user, have a look at it, and perhaps, well, we see there's an outlier, the user will analyze the outlier, perhaps decides to exclude it from the estimate. So then finally, when all is set, the user can click on calculate regression, and then CostFact calculates different regression types, which are often, well, shown in practical application cases, also calculates stability index and so on, and proposes the one with the highest stability index. So this result can be used if I have a current estimate to make my cost prediction, or I can click on save this cost regression function to the function pool, and then it's put to this function pool. And from here we can use it if when we're working on an estimate and we are going to parameterize the cost model to search for existing functions which have been defined before. Of course, all the relations to the reference projects are stored. If there are updates because something was wrong, it will be updated out. Not completely automatically, the user will get an alert. You can update if you like. So finally, just an example how it could work in the estimation process when we put all these things together, all these different features. So here, when I start or when I work on a hull, and the target is to calculate the total cost of the hull, the first step is to get from the CAD system the information of the hull mass. Pretty easy, have it in CostFact, and then from the ERP system provides information how many dollar is 1 ton steel in this case. So putting both together, I have the information about the direct cost for the steel. Of course, this is only one part of the entire cost of the hull. So in the next step, I can apply these parameterization functions. So for all these cost lines which are parameterized, we can calculate the resulting number of labor hours and the cost as well. And for the rest of these of the cost items which are not calculated directly, not part of the parameterization, then we can make use of the regression function by creating in the first step across projects these regression functions for all these remaining PBS elements or SLAPIS codes. We have the cost functions, which then can be applied to calculate the labor hours and the cost for all these remaining cost items. So by doing so, the entire hull is calculated. And of course, the more information is available from the design system, the better this approach can be used. And that is the reason why changes, where we have usually a very high degree of or a lot of design model data available, this can work well nearly automatically. So the design change comes in, We have the update in the on the technical side, update the cost model, and we can deliver our quote for this change request. So that was a presentation. If you like to try it by yourself, you have the possibility today to do so. So at 1 o'clock, we're having the workshop where everybody who's interested in can work on a laptop with a full version of CostFact. We have a tutorial where we can go through, but you can also try things by yourself. So we can do everything what you've been seeing here. We can do some more things like calculating cost of ship series, bringing costs on the timeline, time phasing, and such things. And of course, you're warmly invited to join us at 1 o'clock in, I forgot the name of the room, but I think you will find out. Thank you very much. And of course, if you have questions, please feel free.
Are you using any Monte Carlo analysis for risk associated with the time of the project?
About the risks?
Risks associated with the time and duration of the project. So you,
okay.
You do your parametric to get the number, but then there's some risk associated with that number or duration or price variability.
But we have it not implemented. You will see it in the result. If you see how the projects spread, you can have, for each project, we have information on the time, and then you will see that the risk is increasing. But we have not a feature that will automatically give the information about the quantification of the increasing risk. Okay, 9 cups, room 9.
So I guess it was probably about 6 years ago that we worked on a project called Dynamic Change Awareness. And many of you probably sat in on some of those sessions where we mapped the entire change management process at Ingalls, Austell, and Bollinger. And one of the common threads that we found in each one of the shipyards was how they approached pricing a change. And it led to a common thread across all shipyards. And at that time, everybody pretty much was doing it the same way. Right? They were passing a spreadsheet around, a form, and everybody filled in their information. Each department added their number based on certain information. And it kind of led us to look to a solution, a shipbuilding cost management solution to maybe help in that process. So that project led us to seek out Jan and his product. It was being sold by several other SSI resellers as a product to service some of the other yards. I think it was our South American dealer, Yako, yeah, that I contacted because he was a reseller of CostFact. So 6 years ago we met, started talking about some of these things because of a research project and a technology that could help with shipbuilding. So encourage you to, if you don't have Jan's number, even if it's not something you think it's gonna maybe affect you, but could affect another department. Because I truly believe we've written up projects around model-based change management. We submitted to NSRP. It wasn't selected this go around, but I think it's coming, especially with the fact that we're getting tighter budgets. The time frames for change orders are lengthy. And if you're able to use the 3D model to analyze a cost estimate based on a parametric program like this, I think we're gonna be seeing the need for that in the near future. So I just wanted to point that out and plug for